Good evening, everyone. I'm doing this quick little video to show that the build and installation process actually works. What we have here is just a standard Windows laptop that I'm running SignApk on, that I'm connected to the development machine that's running the build scripts. Now, the build scripts have already completed here, and I've written the resulting update.zip to this USB flash stick here. So I'll take and remove it. And we're going to go down the hall here. Into the other room here. And here we have our Aml8726 board sitting here just waiting. I'll take and put the USB stick into the slot. 1 second. And we're actually going to take, since this machine's already booted here, I'm going to take and reset. But I'm going to hold down the update switch first for a moment. Press the reset for a few moments. Let go. Wait for the USB light to come back on. And with that, we have our update screen. This is, of course, the standard Android updater using the Edify scripting language. And we have a zip that we've signed and verified with SignApk. It first goes ahead, shows us our little greeting. It updates the kernel real quick, a U image that we flashed to boot. Formats the system partition, mounts user data, because we'll be using that to hold the file system package for a moment. And then we unpack BusyBox for tar. Now, tar is, BusyBox is special in this case because we need it specifically for tar. And we need it because Edify, since it expects everything to be able to be unpacked from a zip file, we can't just shove a Unix file system inside the zip file and expect it to work. What we do instead is we tar up the file system as part of the build process, and we put a statically built version of BusyBox in tow for it. This process takes anywhere from roughly 1.5 minutes to 5 minutes, depending on the size of the file system. It is worth noting that you have roughly 1.7 gigs available on user data from a factory installed box on which you can basically put, that's the largest, probably the largest file system that you can cram onto it, but also worth noting that system itself is 200 megabytes. So be very careful to put your file system and make sure that it fits within the 200 megabyte limit. So after this is done, it takes and unmounts everything and reboots the system. Now, in this particular build tree that I have here, I've added a couple things to the extra files part of the file system so that it will have a video file and a little script that it calls from a init to play a little burn-in video once it's actually active and ready. Give it a moment here to do it. And we have our video playing with the codec that I wrote a couple weeks earlier. As you can see, plays quite nicely. Done. And just to show you that this is actually working entirely off the NAND, I will repeat the process by removing the USB stick from the device, and I will take and press the reset button again. Now, it is worth noting that one of the indicators that I use for testing whether the kernel is active or not is I watch the network indicator to make sure that the network lights come on. They should come on any second now. See? And with that, we have our video. So this is just an example here. We can take and do whatever we want to here, but I did this just as a quick little burn-in to verify that everything was working properly, and it was something that could be tested without needing to hook up any TTL cables. So with that, I bid you all a good evening, and onward and upward.